Hello, this is Shakib Ghazi and we're discussing about geometrical optics, and today we'll continue discussing about some very important topics which are important for both our HSC exams and our admission exams. So let's continue. If I have a well, there's a pond, we can say. If there is a pond and suppose we have an object here, and if someone outside of the pond is looking at this object, let me draw a perpendicular line here, and this is our surface. Okay, sorry, let the object be in here. So from this object the ray will come in this direction, and since it's a well and here is water and water is denser than air, so this is our incident ray. The incident angle will be smaller than the refracting angle, means the ray will go away from the normal. The ray will go like this way. Now this angle R will be greater than angle I. Why? Because the light is traveling from a denser medium to a rare medium. So now what's happening? If I extend this line, so the object which was actually here will be seen by the person who is outside of the pond in this position. So this is the actual position of the object and this is the apparent position of the object. From these two positions, the actual and the apparent positions, we can actually determine the refractive index of this medium. In that case, the refractive index of this medium will be actual distance by apparent distance. Or we can also say distance of object. The actual distance was the distance of the object. The distance of the object by distance of the image. See, one thing is that in this formula we considered that the person who were outside of the pond is actually in air medium. But if we don't consider this phenomena, or we consider other phenomena where we are actually in this formula we know the air's refractive index is 1. But if we have any other medium where this phenomena would take place, but instead of that there is no air medium, there would be any other medium, in that case the formula would be refractive index of this medium, or we can say the refractive index of the medium where the object is actually present. So refractive index of the object, refractive index of the medium where the object is present, divided by refractive index of the medium where the viewer is present. Viewer. Or also you can say refractive index of the incident medium divided by refractive index of the refracting medium. So sum up, we can say the formula is new object by new viewer is equals to u by v, or new if the viewer is in air medium is equals to u by v, where u signifies the distance of the object or the actual distance, and v signifies the distance of the image or the apparent distance of the image. Apparent distance of the object. Okay. So I hope you understood this formula. Now let's do one math about this formula.
So the first math is that it's given.
Okay, the first thing first, this is not from your textbook. I'm following another reference book. However, all these questions which I'm solving right now will be given in a link on the comment or in the description. Just see there and you will get the question. Now see, it's given that 1/5 part of a container of height 20 centimeter. Suppose I have a container of 20 centimeter height. This total height is 20 centimeter.
1/5 part of a container of height 20 centimeter is immersed in a liquid of refractive index 1/3.
So 1/5 means 4 centimeter, right? So 4 centimeter, suppose this is a 4 centimeter, and in these 4 centimeters we have we inserted a liquid of refractive index 1.3, and the remaining part, so if this part is 4 centimeter, the remaining part will be 16 centimeter, and the remaining parts is filled with another liquid of refractive index. Let's give it a refractive index of 1. This is 2 of 1.4 refractive index. Now we know,
from above, what will be the apparent depth of the container?
so what will be the apparent depth? So in the formula that we have previously learned, that is nu is equals to u by v. So what was u? U was the real distance. So real distance is given, that is 20 centimeter. What will be the apparent distance due to the change of refractive index or due to the presence of fluid in the container? So the apparent distance formula is v is equals to u by nu. But the problem here is that we are having two types of liquid with two types of refractive index. So in that case, we'll be having two apparent distance, right? So then name them as V1 and V2. So summing V1 and V2, we will be getting our actual desired apparent distance of the entire container. So V1 plus V2 is equals to, we can write U1 by nu1 plus U2 by nu2 is equals to, so u1 by u2, let's put the value. U1, suppose for this one, is 4 centimeter by 1 by 3 plus 16 centimeter by 1.4 is equals to 14.5 centimeter. 14.5 centimeter. One thing you will notice that for every math, the apparent distance, that is V, is always less than the real distance.
Okay, now see for another math. In a container, there is a plate of thickness 10 centimeter.
So we have another container. Suppose this one is another container. We have a plate of thickness 10 centimeter. Suppose this is our 10 centimeter.
it has a layer of liquid of thickness 5 centimeter above it.
It means that above this 10 centimeter thick plate there is another liquid of 5 centimeter,
and above that there is a layer of water of depth 4 centimeter.
above this liquid there is a layer of water of 4 centimeter.
If we look straight, how much the depth of bottom of container will appear, how much will be its apparent displacement. So refractive indices of glass, liquid and water are 1.6, 1.5 and 4/3.
So here nu G is equals to 1.5, nu liquid is equals to new glass is 1.6, 1.6, this is 1.5, and new water is 1. They have without given in point, they have given in 4/3. Okay, so here again, since there are 3 layers, so we'll be having 3 apparent displacement or distance. So V1, V2 and V3. So V1 plus V2 plus V3 will be our apparent displacement of the entire container. So V1 we can write, V1 is equals to U1 by nu1 plus U2 by nu2 plus U3 by nu3. So for the first layer we have 10 centimeter thickness and 1.6 plus 5 centimeter by 1.5 plus 4 centimeter by 4/3,
and eventually for calculating we will get a value of 12.583.
12.583. So in the question they asked about apparent displacement. Here we found apparent distance. So displacement means from the actual value how much it has deviated. So the actual value was, our actual height was 10 plus 5 plus 4, that is 19 centimeter. But the apparent distance is 12.583 centimeter. So what is the displacement? Means how much above or how much below we are seeing the surface. In that case the displacement is, apparent displacement is actual distance minus apparent distance is equals to 19 minus 12.583 is equals to 6.417 centimeter. Okay, now we already learnt about critical angle. So what was critical angle? If I had one surface like this, and this is the denser medium, and this is the light medium. So denser medium, suppose it has a refractive index of nu1 and it has a refractive index of nu2. So since it is denser medium, its refractive index will be high. That is, so nu1 will be greater than nu2. So in that case, if one light is incident on the surface, it will go away from the normal. But in case of critical angle, we know the critical angle is the incident angle from the denser medium when the light travels from denser medium to rare medium. Critical angle is the incident angle for which the refracting angle becomes 90 degree. Means, suppose this is our critical angle. So to become 90 degree with what? With the normal drawn on the surface of the medium. So drawn on the surface. So if this is the medium, the 90 degree will be along the surface. Means if this is the incident ray, the refracting ray will go along the surface. So the angle or the incident angle created is called the critical angle, theta c. So critical angle is always incident angle. So we can find this critical angle. So the formula for finding the critical angle is sin theta c is equals to refractive index of the light medium divided by refractive index of the dense medium. Okay, so they have told critical angle of glass with respect to air is 42 degree. Critical angle of glass with respect to air. Critical angle of glass, that is theta c g is equals to 42 degree. Since the critical angle is respect to air, so we can write sin theta g or sin theta c for glass. For glass, sin theta c g is equals to refractive index of the light medium divided by refractive index of the denser medium. So refractive index of the light medium between air and glass, which one is the lighter medium? Air is the lighter medium. So we can write nu A by nu G, or sin 42 degree is equals to nu A by nu G, and we know the value of nu A, which is 1. Again, they have told critical angle of water with respect to air is 48 degree. Critical angle of water, that is theta c w is given as 48 degree with respect to air. So we can again write sin 48 degree is equals to refractive index of air or the lighter medium, which is 1, and refractive index of water, which is nu w. Equation 2. We'll be getting on value for sin 42 degree and sin 48 degree. I know you are enough intelligent to find the value of sin 42 and sin 48 degree. So they have asked what is the critical angle of glass with respect to water. So critical angle with respect to glass and water. Now tell me which one is the lighter medium between glass and water. Water is the lighter medium, right? So for that, sin theta c for what? For glass and water is equals to refractive index of water medium by refractive index of glass medium. So from here we will be getting the refractive index of glass medium. From here we will be getting the refractive index of water medium. Put this value here, then find theta c is equals to sin inverse nu w by nu g. So the next math is
with respect to air whose critical angle is greater between glass and diamond. So they have already given the refractive index of glass and refractive index of diamond, they have already given, which is 1.51 and 2.47. 1.51 and 2.47. So with respect to air whose critical angle is greater between glass and diamond. So with respect to air, so let's find sine theta Cg is equals to refractive index of air, which is 1, and divided by the refractive index of the denser medium, which is the glass. So nu G. Suppose this is one equation. Again, for diamond, sine theta C D is equals to, since it's with respect to air, so the refractive index of the lighter medium, so